Another couple of concepts um, which we need to know when we deal with random variables, and one of them is expectation. So sometimes it's not very convenient really to talk about probabilities. Sometimes you really want to know what is your expected outcome, or on average, what should you expect. Um, so, for example, when you talk about the sales for the next quarter, and you try to convey a message in a simple form, instead of giving a probability distribution function in your presentation, you might as well just say we expect that the sales going to be, and you have to give a specific number. And so expectation is essentially a way to give the specific number that's weighted average across all possible outcomes. That's all it is. Um, and the way we calculate this weighted average is we take all possible outcomes, and the weights are just probabilities of each of those outcomes. Okay. And so very specific example, when you have n equally likely outcomes, then the weighted average is just average, arithmetic average, out of those numbers. Okay. So let's look at a specific example. Let's look at the roulette. We look at the European version of the roulette, when you have 36 numbers, 18 red and 18 black, plus 1 0. So if you bet $1 on 11 black, the payout is 35 to 1, meaning that you get your $1 back and $35 on top of it. And what we would like to know, what is the expected return on this bet? And let's say X is the outcome of the bet, and expectation of this outcome is just how much we expect to get back on $1 bet. And there are two possible outcomes. You win or you lose. Okay? And the probability of winning is 1 over 37. Because you remember there are 37 numbers, 36 numbers plus 0, and only one out of them will lead to the win. And if you do win with probability 1 over 37, you get $36 back. So you get your $1 plus 35 on top of it. So probability of winning times amount of money you get if you win. And then another possible outcome is you lose, and the probability of this is 36 divided by 37. In 36 cases out of 37, you lose. 11 doesn't come up. And then you get $0 back. You basically lose your dollar. Okay? So that's the probability, and that's another possible outcome. So your win is either 36 or 0, and those are the probabilities of getting 36 or 0. So we take the weighted sum, and so we get the number 0.97 at the end. The way we interpret this number is that if you bet $1 on 11 black, then you expect to get 97 cents back on this bet. In other words, casino has a 3% edge, or 3 cents on the dollar edge over your bet. Okay. So let's look at another bet. If you bet $1 on black, it pays 1 to 1, meaning that if you win, you get your $1 back plus $1 on top of it. And then again, there are two possible options: you win or you lose. The probability of winning is 18 divided by 37. So 37 numbers, 18 of them are black. And then you get $2 if you win. Probability of losing is 19 divided by 37. So 19 red plus 0. And then you get nothing on your bet, and again you get the expected value is 0.97. So it doesn't really matter whether you bet on the number or you bet on a color. Expected return on your bet is the same, 97 cents on a dollar. So this 3% edge, or 3 cents edge, is essentially how casinos stay in business. They basically take a little bit on each of the bets, and in the long run, essentially, casinos are guaranteed to make money. Standard deviation and variance is another concept, and essentially it measures variability of outcomes related to the expected value. So mathematical definition is that variance is just expectation over deviation of the random variable from its mean or from its expectation. So you say, okay, I have my expected value e of x, okay, and I'm gonna calculate how much outcomes x deviate from this number. But if you just look at this number, you can have positives and negatives here. So sometimes the difference is positive, sometimes the difference is negative. So in order to avoid the cancellations of positives and negatives, we actually, instead of looking at the difference, we're going to look at the difference squared. And then we calculate the expectation over this difference squared, and we call it variance of the random variable x. Okay. And if you look at the units in which the variance is measured, so let's say x is measured in dollars, then expectation of x is also measured in dollars. And then the variance of x is going to be measured in dollars squared, which is not very convenient if you think when you try to talk about variance and when you try to assign some meaning to it or try to have some intuition about this, then measuring something in dollars squared is not very convenient. So for the sake of convenience, we might as well use standard deviation, which is just the square root of the variance. And the standard deviation of x, if x is measured in dollars, is going to be measured also in dollars, as in the casino example. So let's look at the variance associated with the roulette example again. So again, we have a European roulette, and again, we're going to consider two types of bets. First, when you bet on 11 black, and the variance, you remember the expectation of the deviations of the outcome from its mean, from the expectation. So remember, we calculated that expectation of x was 0.97. That's what we calculated in the previous slide. And so in the case of winning, you have 1 over 37 chances winning. Okay, and then the deviation is 36. That's how much you get, minus expected win 0.97, 97 cents. So we take this number squared, multiply it by the probability of winning. And another outcome is you lose. So we take, if you lose, you get 0 back. So 0 minus 97 cents squared times the probability of you losing. So we get the variance of 34, which is relatively high. Now let's look at the variance of a bet on a color. If you bet $1 on black, then again we do exactly the same calculations. Then it's $2 minus $97 squared times the probability of winning, plus 0 minus 97 cents squared times the probability of losing. So variance is 1. So how do we interpret this now? Variance of bet on a single number is much higher than the variance of a bet on a color. It means that if you come to a casino and your goal is to stay and play there as long as possible, then you might as well prefer a bet with lower variance. Lower variance means you're less likely to get wiped out in a single bet. So you might lose, but you'll be slowly losing, so it will take you longer to lose all your money in a casino if you bet on the color rather than betting on a specific number.